Hello guys, welcome to Backbencher Studies channel. In the last video, we have discussed how to solve a problem based on Mason's gain formula. And if we are given with a signal flow graph, and we know how to solve the overall transfer function based on the signal flow graph based on Mason's gain formula. We already learned about finding the determinant of the isolated path and the entire signal flow graph. So in this tutorial, we are going to learn some theory concepts based on the systems. So let us start our session. So we have the type of system. So the type is defined as the number of poles at s equal to 0, that is s at origin. So if we have we know that if you have the transfer function polynomial, we can have the numerator polynomial as well as the denominator polynomial. And if the roots of this numerator polynomial are called zeros, we already know that. We saw that in signal and system course. And the roots of this denominator polynomial are called the poles of the system. So if we have a pole at origin, then that will be called as a type 1 system. So based on a pole at s equal to 0, we have the type of the system. So let us see, let us determine the type of system of these transfer functions. So in the first example, we have the transfer function is equal to s plus 1 by s plus 2 into s minus 1. Here we have a 0 at s equal to minus 1, because that is the solution for this numerator polynomial. And we have two poles, one being minus 2 and one being 1. So we have overall, we don't have any pole at s equal to 0. So we can say that this is a type 0 system. So as there is no pole at s equal to 0, we can say that this is a type 0 system. So, and if we have, so let us move on to next problem. So this is the overall transfer function g of s is equal to s plus 1 by s into s plus 2 into s minus 1. So here we have the poles at s equal to 0 and s at s equal to minus 2 and at s equal to 1. And we have a 0 at s equal to minus 1. That's not a matter. So here we have a pole at s equal to 0. So this system, these type of systems, so the systems with these type of characteristic equations or these type of transfer functions are called as type 1 systems. So a pole at origin will make it type 1 system. So this is a type 1 system. And if we saw the third example, we have two poles at origin, that is two poles. And if we see this is s square now, so s square can be written as s into s. So this s into s will be leading us to two poles at s equal to 0. Thereby the type of the system is type 2 system. So this is how we can determine the type of the system. So let us see what is an order of the system. So order of the system is defined as the number of poles is equal to order. So based on if we see the overall transfer function, the denominator polynomial is called as the characteristic polynomial, that we can see. The order of this characteristic polynomial, the highest power of this characteristic polynomial is what is defined as the order of the system. So this is how we can say a type, we can define the type and order of the system. So let us quickly move on to some problems. So we have example 1, find the order and type of the system. So here if you see the overall transfer function, we have a 0 at s equal to -1, and we have three poles at s equal to 0, s equal to -1, and s equal to 1. If you are thinking that this is a type 1 system, uh, because it has a pole at s equal to 0, then you are correct. And if you are thinking that this is a third order system because the highest power of the polynomial characteristic polynomial is 3, then you are wrong. Why? Because the poles and zeros cancels out. This phenomena we already saw in signal and system course. So we have a pole at s equal to -1, and this 0 at s equal to -1. They both being cancelled will result into the overall transfer function as 1 by s into s minus 1. So if we consider this after cancelling the common poles and zeros, we have to find out the order. So if we cancel both of these, we can have the order of the system as 2, the highest power. So this is how we can find out the order of the system and the type of the system. So this is a type 1 system and order 2. So let us move on to next problem. So here we have 1 0 and 2 poles, 0 being at s equal to -1, and poles at s equal to -4 and s equal to 1. So we can easily say that there is no pole at s equal to 0. So we can say that this is a type 0 system. And we can, if we observe the highest order of this, highest power of this characteristic polynomial is s square. So we can say the order of the system as second order system. So this is a type 0 second order system. So this is how we can say the type and order of the system. I hope you like, I hope you understood the concept. So if you understood the concept, please do like this video and please do subscribe to our channel. Thank you guys.